Um, it is on antimicrobial resistance. I hope many of you all might have heard about it. It is closely associated with the problems that we are facing today in the world. So we have Dr. Debashish Banerjee with us, who is a translational biologist, and he is presently working on AMR, then AMT, anti-cancer and antimicrobial therapeutics. He is working as an assistant professor for research at the Biotechnology department at our university. He has previously worked in research laboratories as well as with the UNESCO Center for Marine Biotechnology. And we are very fortunate to have him. He is a very well known researcher, and he does a lot of research, collaborative research with many people across the globe. And we are very fortunate to have him. And this was something that is a lot of concern that we all want, you need to know about. So I request Debashish sir to please take the session.
Thank you. Thank you all. Okay, so Jai Sunarayan and good morning to all of you. First of all, I am very thankful to the university and especially Sheetal ma'am for arranging this, and giving me an opportunity to share a few knowledge with you. Okay, and also I am really grateful to her. Okay, for arranging this kind of things for knowledge dissemination, so that we all come to know, what are some of the burning topics in the world now. Okay, so as we know more, our minds also get activated, and we can think about something that we want to pursue ahead. Anyway, so let us begin now. So as you can see, today's topic is antimicrobial resistance, the next COVID-like global health emergency staring at the world. Okay, so why before going in further, I just want you to know why this COVID-like, why I have put the word here. Okay, because as we all know, COVID was a very dangerous global health pandemic that we have all recently faced. Okay, there was so much of death, mortality, and morbidity, disease around, we have seen. And after that, now somehow we have come out of it, or we have managed this to an extent. But there are many other health emergencies or issues that are just lurking at the back to strike at us. Antimicrobial resistance is one among them. Okay? So before actually knowing anything about antimicrobial resistance, we should know what the word about antimicrobial is. Okay? I think since the crowd, most of us here is from pharma, right? So you must be knowing about these words, you might have at least heard about this. So, an antimicrobial agent, as you can see, is, anything that actually inhibits a microorganism. Any compound or substance that can, is capable of doing that can be called or classified as an antimicrobial agent. So what does it do? Generally, as you can see, it can inhibit the cell wall synthesis of the bacteria. Okay? It can depolarize, or as such for other microbes also. Okay, that means it can disrupt its outer cell membrane. It can depolarize the cell membrane. It can inhibit the protein synthesis. It can inhibit nucleic acid synthesis. Also, it can inhibit the other metabolic pathways operating inside it. That means inside the cell. So it can act both on the outside of the cell, that is the bacteria, and also inside it. It can go inside and disrupt many kind of metabolic or physiological pathways inside the cell. Any compound that is capable of doing it is called an antimicrobial agent. So, similarly, antibiotics is one example of them, right? So we all know generally, when you heard about the term antibiotics, we know that it is some kind of medicine which is directed against the bacteria or microbes. This much of general idea we all have. But now let us look, okay, what does, generally or overall an antibiotic does. So as you can see, antibiotics can be classified as anti, meaning it works against something, and that is what? A bacteria or a particular pathogen, right? And it can stop or kill that particular pathogen, for example, the bacteria. So antibiotic is again any kind of antimicrobial compound, okay, that can inhibit or kill the bacteria, okay? And not only the bacteria, antibiotics are also capable of inhibiting other kind of microorganisms, for example, fungi, viruses, protozoa, etc. Okay? So, generally it can be called as medicines or drugs used to prevent or treat the infections or diseases that are caused by bacteria. The word antibiotics is clear to all of you? That means generally it can kill or stop the growth of the bacteria, preventing its further, proliferation. And it can be naturally derived or it can be synthetic. That is artificially made or synthetically made, manufactured. Now most of the antibiotics that are currently in practice today are actually man-made. So this figure gives an idea about the different mechanisms of action of the antibiotic. Okay, for example, as you can see, it can inhibit the cell wall synthesis. Also, it can go inside the cell and it can affect different kind of metabolic or the physiological pathways inside the cell. For example, protein synthesis, DNA metabolism, and so on. Okay, so it is capable of affecting the bacteria in many ways. On its outside, that is the cell membrane, also inside and in different kinds of metabolic processes inside. So all these things actually kill the bacteria or inhibits its growth. Okay? Now, there has been, antibiotics has been in use for a long time. Okay, since from the start you all know. Okay, which was the first antibiotic? Penicillin, very good. Okay. So it is a long time, it is there in use, and many antibiotics have been, after that, it has been discovered or synthetically made, which was active against lot of kind of microbes or used to treat different kinds of bacterial infections. And it was going on. The field was very nice. Okay, lot of diseases were stopped, but down the line, that means recently, or rather recently, from few years, we get to hear all these things. Okay? Meaning that antibiotic is not, anymore active against the bacteria. It is not able to kill the bacteria, or the bacteria, or the pathogen, be it anything, virus, protozoa, etc., they have grown resistance against that antibiotic, meaning that antibiotic is no more useful in treating the infection. Now, how does it happen? As you can see, now almost on a regular basis, you get to see many kinds of report which says that new antimicrobial or antibacterial species are coming up or evolving, which are absolutely resistant against the antibiotic. That means the antibiotic is absolutely useless against them. Okay, so these reports, actually tell the gravity of the situation. And almost, these days the reports are every day almost you get to hear about a different kind of antimicrobial resistant strain. Now, this slide is actually a report by the Review of Antimicrobial Resistance done globally, which says, this depicts the severity of these kind of antimicrobial resistant strains. If you can see, antimicrobial resistant bacteria that is causing infection or disease is killing around 7 lakh deaths worldwide. Okay? In the world, every year, 7 lakh people die because of infections or diseases caused by antibiotic-resistant bacteria. That means against which the antibiotics don't work anymore. Okay? and 50,000 people are die every year in the Europe and US alone. Okay, so now you can see how important this scenario is. Okay, slowly we are moving into a situation where no of the antibiotics will be effective. As you can see again, there are again certain reports or facts to justify it. In 2016, multi-drug resistant TB killed 5 lakh people. Okay, E. coli, which is a very common infection, I know, which is actually a commensal of the human body and causes some simple infections, but it has also developed resistance. Similarly, Klebsiella pneumoniae. Okay, and these infections, they are changing into superbugs. That means again resistant strains. Okay, according to the estimates by different world governing bodies like WHO, FDA, CDC, ICMR in India, and many others across the world, antimicrobial resistant bacteria causing diseases, okay, will kill 10 million people worldwide by the year 2050. Okay, so around, say, maybe around 25 years. So these AMR strains or antibiotic resistant strains, which causes different infections, can kill 50 million people in the world. So the World Health, now slowly different kinds, the world, different kind of regulatory agencies, the governments have taken this into notice. And they have stated, the WHO, the World Health Organization, has stated that AMR is one of the top 10 concerns in the world. Top 10 health concerns in the world which require immediate action. Okay? And now, it is even more important because it is not only a threat to health, but it is also a threat to safety, security, and economy. Safety, why? Because these kind of strains can be used as bioterrorism agents by terrorist organizations, to disrupt the life or the society in other places. Security, safety, and economy. Why economy? Because if a major portion of our, the government GDP goes after treating these infections, okay, the GDP will be affected severely. A major portion of the finance or the funds of the government will go after the treatment. That's why it can also impact the economy severely. We all know the COVID, what happened. Such a small virus particle, which you cannot not even see, you cannot see by the eye, it has caused destruction globally, killing, okay, people, downing the economy, okay. Still we are recovering from that. Okay, so this is again a similar situation, just in waiting. Okay, and so it is an important issue, and it demands the immediate the search or the immediate research to look for new kind of antibiotics. Now, as you can see, now this is a very important statement. It says that, again, declared by the health agencies, most of the pathogenic microorganisms, okay, that means, which pathogenic means, it can affect the humans, okay, it can cause disease. They are, each and every microbial pathogen today is at least resistant against one antibiotic. Okay, each and every pathogen almost existing today is resistant against one antibiotic. कोई ना कोई एंटीबायोटिक्स के अगेंस्ट में वो रेजिस्टेंस है और वो एंटीबायोटिक उसको मार नहीं सकता है, उसको कोई भी हार्म नहीं कर सकता है. Okay, see the alarmity of the situation. Okay, it is a serious. That's why it's a serious public health threat, and resistance. This antimicrobial resistance has been a cause of morbidity and mortality worldwide. That means each and every corner of the world is now under threat by this AMR resistant bacteria. Now, what are the hotspots of antibiotic resistance? There are no hotspots because, as I told you, each and every corner or city of the world is affected by it. Okay, it can crop up anywhere. Okay, and so just one example in that sense. Okay, the Ganges River, we know in our river, Ganga, okay, which is sometimes called as a Mother Ganga. In Ganga River itself, it has been found that antimicrobial in recent times, antibiotic resistant bacteria has been increased by 20 times. So in a place like Ganga, where which is such a which is having water current moving in such speed, if there in that environment it can increase 20 times, just imagine about the other places which are crowded or there is no health and sanitation. What is the case there? What is the scene there? Okay. Recently I was also, and I have been, I know I'm interested in this field for quite some time, and recently I did a research which clearly pointed out, it was a survey done in 2019 itself by some of the BSc students. They have found, okay, they have visited many hospitals and diagnostic centers in and around Rajkot, and they have found that, okay, each and every hospital or clinical setup, there was a report of antimicrobial resistant strain bacteria right here, right in our vicinity, in our city. Okay, like this, if you go anywhere in the world, okay, this thing is coming up in a very dangerous situation. Sorry. So, okay, yeah. So we know we have known about antimicrobial resistance. Okay, what it can cause, what is the severity, but what is antimicrobial resistance? We have to first understand this. Okay, so if somebody asks you what is antimicrobial resistance, okay, fine, it's causing, but what is it? So antimicrobial resistance is called the inherent ability of any microorganisms which helps them to overcome the action of antibiotics. Okay, which helps them to inhibit the action of the antibiotic. Okay, so as you can see, to resist the action of the antimicrobial agent, that is the antibiotics or any other kind of antimicrobial agents, that then they develop that resistance of the power to be ineffective or to make the antimicrobial agent ineffective, and that inherent power then grows in it slowly. Okay, how we will see in further. Sometimes we saw that each and every microorganism today is almost resistant against at least one antibiotic or antimicrobial agent. Sometimes that bacteria or that microbial species can develop resistance against number of antibiotics at the same time. That time it is called multi-drug resistant or a superbug. Okay? Okay, like something you call a superhuman we saw, so the bacteria becomes a superbacteria. Wow, superbacteria because it can resist or it can inhibit number of antibiotics at the same time. For example, suppose you try to kill it or stop it by using 8 antibiotics, it is showing resistance against all. Okay? And so another report in that direction, you see in the United States, USA, 2.8 million infections occur every year. 2.8 million infections caused by antibiotic resistant bacteria. And 35,000 people die every year because of this, only these kind of infections. Okay, 35,000 every year, only in one particular region. We are talking about USA. Just imagine in the whole world what will be the number. Now, so we know about antimicrobial resistance. We know the severity. Now, a very pertinent question may arise in your minds that why does the bacteria does so? Okay, why it turns out to be a villain? Okay, because of two very simple reasons. First, it just wants to survive like any other organism or species in the world, including humans. Like whatever difficult situation we have, it's a natural tendency, like for everyone to surpass it or to exist in that. The bacteria are no exception. It just wants to live, it just wants to survive, number one. Number two is, Okay, we know of the many kind of fashion designers around the around the world who does a lot of beautiful clothes and all. One of the best designers in the world is bacteria. Why? Because it has many many tactics or many ways to develop the resistance against the antibiotic. बहुत अलग अलग तरीके से ये उस चीज को कर सकता है. Resistance against the antibiotics. How? It can mutate its own DNA. Number one, that's called mutation by genetic changes in its own DNA. It can also acquire the resistance from outside. That means from inside it can do, from outside also it can do. Okay, how? By taking those resistant genes from other bacteria, okay, like extra chromosomal plasmid or certain kind of these resistant genes, okay, through the processes like transposition, conjugation, etc. Okay, so both ways it can do this resistance. So see how capabilities the bacteria. The major problem of humans is that we don't want to see anything beyond us. But if we appreciate the capability of other species in the world, maybe we can coexist with them much more in a much better way. Okay, so it's very important to know how we can do that. What are the mechanisms of different species they use. So this example shows you or gives you an idea that what is again the situation, how slowly each and every bacteria or pathogenic organism is developing antimicrobial resistance in the world. If you see, you name it and you find it, it is already resistant. For example, methicillin resistant Staph aureus. Methicillin is one of the final compounds to treat Staph aureus infections. It has grown resistance. Okay? Streptococcus pneumoniae, carbapenem resistant enterobacteria. Again, carbapenem, methicillin, these are one of the last generation antibiotics to treat. मतलब last weapon है ये bacteria के against में, ये particular bacteria के against में, but they have developed resistance. Okay, these are the last generation antibiotics are also no longer useful to treat these infections. Okay, in many of the reports found worldwide. Escape is a term that is used for certain again kind of microorganisms. As you can see, Enterococcus, Staph, Klebsiella, Acinetobacter, Pseudomonas. Okay, and these are very notorious. That means they can cause hospital-acquired infections. Now, this is a very, again, dangerous scenario. Okay? Maybe, again, we have heard during the COVID time, there was, the risk or the danger of certain kind of associated infections like black fungus, yellow fungus, which is all coming up, right? COVID से ही पल्ला नहीं छूटा था और, virus से फिर दूसरे type of organisms भी उस time they have started affecting us. Right? Black fungus, people who are in the ICU, they were developing yellow fungus, and then, slowly everything was coming on black, yellow, and God knows what else. Okay? They are called associated kind of infections. So, there are some kind of unknown threats also. Now, these organisms which come under the escape, they can cause hospital-acquired infections. This is again a very dangerous thing. It has been found that the patients who are admitted in hospitals from a long time, they acquire infection from the hospital itself, which is the place to actually treat them. Okay, they acquire or can acquire many kind of infections from the hospital itself. Many people around the world, they develop these kind of infections. Sometimes they are very dangerous and they can even cause severe mortality again in the long run. So many of these escape organisms have also been found to be antimicrobial resistant. Okay, so after if someone suppose affected by this kind of AMR strain, they get admitted from some kind of disease. Okay, they get cured of the disease, but after coming out, they acquire this kind of infection. Okay, and then that is a different episode. Then again there is no treatment for them, and then
the problem continues. Certain other examples, again certain kind of important species which are posing antimicrobial resistance in a big way, like Acetobacter, Candida auris. These are, the fungi, Clostridium difficile, carbon and Enterobacter, and drug-resistant Listeria gonorrhoeae. So now we have seen the different slowly how each and every organism is developing resistance. Now, why? Actually, what does cause this resistance in the bacteria? That also we should know. Okay, what is actually causing it? So, as you can see, main reason for the antibiotic resistance is the overuse or the unregulated use of medicines. Okay, antibiotics which are actually meant to treat this bacterial infection or kill the bacterial species. If it is overused or not used in a proper way, they can themselves cause, this antimicrobial resistance. Okay? So, inappropriate use, multi-drug, that means many drugs prescribed at the same time. Non-completion of the course, that means if you are prescribed a dose, suppose you feel better, we stop taking it. Okay? Insufficient hygiene and management systems. Okay? And non-discovery of new antibiotics. In the last 10 years, or approximately last 10 years, or even sometime more, say last 20 years, very rarely a new antibiotic has been discovered. Okay, it is not easy to discover a new antibiotic. So all these problems, overuse of drugs, okay, not completing the course, unhygienic, unsanitary methods, and non-discovery of antibiotics all can cause antibiotic-resistant infections. Okay? Now, factors which are the factors which actually cause this antibiotic resistance. Okay? So as we saw, the unregulated use of antibiotics is one of the main factors. If we classify the factors, these can be the 4 factors for it. Environmental factors, drug-related, patient-related, physician-related. It is actually associated at different levels. But before we look into the different factors, we must understand one thing. All these factors are responsible for antibiotic resistance, but bacteria, each and every bacteria or microorganism, this resistance is natural or inherent in them. It is happening naturally as a process of evolution. But what we have done, we have actually accelerated the process by all these things. Okay, now we look into one by one. So you understood? Antibiotic resistance is happening or accelerating because of this, but it is something which is common, okay, in nature. It is happening on the day-to-day. But we have, by our man-made actions, we have accelerated the pace. So first, if you see about the environmental factors, these are all the things which can contribute to AMR. Huge populations, now the cities and everything is overcrowded. Everywhere you go, there's a lot of, the crowd, the population is increasing. That's why the spread is also increasing. Rapid spread because of the, more traveling, more transport, more communications. People are taking the infections from one place to the other. Poor sanitation, and unhygienic ways used by the, in different populations or communities, increasing community-acquired resistance. For example, suppose if you go to some kind of slum areas or somewhere where people live in a very close-knit situations, okay? There, it is very easy to transform the infection or the disease from one person to the other. Very fast the transmission happens, okay? Ineffective infection control, कोई proper infection control program नहीं है, or universally it is not implemented. Increasing national and international travel. The more travel, the more chances of transferring the infection. Okay, everywhere. Suppose one person is infected, wherever he goes, there is a potential chance that he will transmit the infection in different places. The same thing what we have observed in COVID also, right? Okay? And increasing widespread use of antibiotics in animal husbandry. Actually, in animal husbandry for animals and other things, it is banned. used for the same reasons, antibiotic use is banned, but still it is happening around in many places in an unregulated way. Okay? And as in the agriculture and all those things. Now, this is again one major threat. It is not because of these environmental reasons, not only the clinical strains, that means the strains which can affect humans, environmental strains are also developing resistance, which are normally not pathogenic to humans, but they are also acquiring this resistance in the environment and disturbing the evolution, okay, and ultimately the ecology of the environment. Why? Because more and more resistant species come, they can wipe out the natural population of bacteria from that place. Okay, and natural, which organisms are helpful or naturally survives, they can drive off them. Okay, so they can disturb the ecology of the environment also in a way. So you understand how, at what different levels or different aspects it can affect. Second is drug-related factors. As you know, it is one of the main issue for this antibiotic resistance, unregulated use of medicines or antibiotics. As you can see, many fake drugs are there. The quality of the drug is not right. That means it is not having the potency or the efficacy. Okay, the use of antibiotics have increased mindlessly. Okay, around in the recent times. Over-the-counter availability. That means you just go to a counter, any kind of pharmacy or medicine shop, you ask for antibiotic, they are just given to you. It is not actually allowed. Okay? By regulation, it is not allowed. You have to produce a prescription for that. तभी आपको मिल सकता है. अगर कोई ऐसा दे रहा है antibiotic without the doctor's prescription, that person, that pharmacist can be actually penalized for it. Okay? And irrational fixed dose combination. Sometimes many antibiotics are mixed and used. Okay? And again, some kind of false drugs or counterfeit drugs or inefficacious drugs which cannot do its role. That means it cannot kill the bacteria. The bacteria survives and develops resistance, okay, along the way. So this you can see, okay, how the antibiotic overuse or the unregulated use has caused a problem. As we just saw some of the things, unregulated use, using when they are not needed, okay, not using the right dose, okay, sometimes for treating some kind of simple infections, bacterial antibiotics are actually prescribed, okay, it is not required, still they are prescribed, and the wrong antibiotic is still given to treat an infection. All these are causing the bioaccumulation, as you can see at the end, the result of all these things, even the, the dumping or the excretion of the antibiotics that is coming out from different industries, like the pharmaceutical industries. They are discharging that in the wrong way, without properly treating it. All these are ultimately leading to, from the drainage system to the water bodies, lakes, to the water systems, and ultimately sometimes the water what we drink at home, we are thinking that it is coming from municipality, it might be very good, but the municipality even does not know that if some antibiotics are persisting in that. Okay, and if we take this, we have also a chance of being affected by antibiotic resistant infections. Any wrong, simple statement here, understand, any antibiotic, even one time you are taking in a wrong way, anybody in the world, you are increasing the chances of antibiotic resistance or antimicrobial resistance in the world. Okay, it's actually a very dangerous thing. I'll just give you an example. Most of the time, again, you might have known during the COVID, certain antibiotics were just prescribed at will. And some people, okay, because they know that, they were even just taking it without consulting doctors. One example was azithromycin. I think everybody knows that. That single use of azithromycin for treating COVID infection around the world has caused so much of increase in antibiotic resistance? Because we should first understand, sometimes, the doctors also are at fault up to an extent. Antibiotic is certain, it cannot kill a virus. We should first understand that. So if you are treating it, we are giving it, it is not doing any role inside us, but some normal bacteria which is, surviving inside us, it has a chance of growing resistant against that azithromycin. Okay, so I just give you one example. Anyway we are wrongly using an antibiotic, we are responsible for increasing the antimicrobial or antibiotic resistance in the world. Okay, so ultimately all these actions are increasing, bioaccumulation means increasing the density of the antibiotics in the nature. Okay, again, which we are digging our own holes. Okay, more resistant bacteria comes and affects us. Okay, so this is an example, it is a real case, not something hypothetical we are talking about. If you see, these reports are some of the reports in some of the best peer-reviewed, widely accepted journals across the world, which says how these wrong actions have increased this antibiotic resistance in the nature, okay, in a big way. Okay, so as you can see, these are direct reports. It is not something hypothetical that we are talking about here. Third is the patient-related factors. We are ourselves responsible for it sometimes. For example, some patients who are prescribed some antibiotics, wo kya karenge? Okay, poor adherence of dosage regimen. They will not take the antibiotic in the right way. Generally, more or less, it's a very common phenomenon, right? We all are, or maybe most of us are actually, sometimes do this. Suppose we take an antibiotic, doctor gives us antibiotic in some certain dose to be taken for a few days. After 2 days, we feel fine and we stop taking it. We are increasing antibiotic resistance. We are increasing the chances of the resistant bacteria to infect that, because the bacteria, if the doctor has prescribed for 5 days and if you stop after 2 days, the antibiotic resistant strains or bacteria inside you have not died out properly. They are still surviving. They will grow even more resistance, more power in the future, and can strike back at you, okay, with more infection at a later time. So, this is my request to you, even certain points which we drive home from this lecture, you please also make aware, okay, and try to lessen the burden of antimicrobial resistance. We should complete the dose as prescribed by the doctor, all of us, okay? And then poverty. Many of the third world countries, poor countries, don't have access to proper healthcare systems. They cannot afford this kind of antibiotics. That's why, okay, they are not, they don't have access. They can use the right medicines, right antibiotics, and these kind of infections persist in them. Sometimes the normal infections persist in them for a long time, in the way developing resistance to antibiotics. Okay? Lack of sanitation concept. It is widespread, okay, around the globe. If you see many regions in the world, they don't have proper sanitation hygiene systems. They are actually not aware of it also. Okay? There should be, the steps should be taken from the government, from the administration to make aware them. All this can lead up to antimicrobial resistance. Lack of education. They don't know the importance, okay, of why these are dangerous. Self-medication, as I told you, sometimes we just know. Okay, some people are taking azithromycin for COVID. I know I am also taking it. Okay, similarly, I am also becoming a culprit in the ring of antimicrobial resistance. We should not use any antibiotics without proper consultation with the doctors. Okay, and misconception about the issue. Many were, okay, still around the globe, if you go, many countries, many regions, they don't know what is AMR, what is antibiotic resistance. Okay? Last is, okay, the physician prescribed factors. Though its, effect is less, or, the chances are less, still the doctors, sometimes the physicians themselves, sometimes are responsible, okay, for increasing this antimicrobial resistance, at least to an extent. Why? Because sometimes they, they don't use the drugs which are already available in the market in the right way. Sometimes they increase empiric poly-antimicrobial use. Empiric poly-antimicrobial use meaning, for, if the doctor assumes, without the proper diagnosis, he assumes that one person may be having an infection, he can just prescribe an assumptive antibiotic, so that if by chance that person is having any kind of infection, that antibiotic will treat it. But again, this is a very wrong thing. I will just give you one example again in this. When I take my own child to the pediatrician, okay, a doctor, he's a very good doctor, and I honestly have a lot of respect for him. But sometimes he just gives him an antibiotic for certain kind of normal, cold and cough symptoms like this. Okay, now there I know the thing, but I cannot argue with him. Okay, that's the problem. Okay, because sometimes the doctors think that scientists don't know much about the treatment. Okay, sometimes. But this is not the case. Okay? I sometimes try to tell him, but then when it is it is required, it is for some kind of associated infection, I have to shut up and see the antibiotic being given to my own child. Okay? So these kind of things are actually increasing it, and then overuse of antimicrobials, unregulated use is being happening around the world, and then inadequate dosing. The doctor is also not prescribing sometimes the right dose. Okay, that means the right concentration of the drug and for the number of days to be taken correctly, and the lack of current knowledge. Sometimes some junior doctors, or sometimes they are placed into certain kinds of setup, like government health centers, or they don't have proper training. Anybody comes having slight any kind of symptom, maybe little sneezing also, antibiotics given to them. This is absolutely wrong, okay? And this is one of the main reasons for increasing the burden of antimicrobial resistance. So you see, this slide tells you how this can spread from the farm to the table. This is again a report, okay, a representative picture from CDC, Center for Disease Control, USA. So as you can see, when these, some kind of farm animals, when they get these infections, they can get, the tendency of the strain is to survive and surpass the normal strain. The yellow color, if you see, it is the antibiotic strain. It will survive and it will wipe out the normal strains there, okay? Then from these animals, it can spread to many other things like, some kind of animal food, where it is where in some regions where people take, okay, some kind of the plant products, some kind of poultry and other products. These will get transferred to the humans when they are actually using this, taking this products, like you can meat or poultry, egg, even when the milk which we are taking. Suppose the cattle is having some kind of AMR strain inside its gut or inside its body, the milk, what we are taking from the cow, they can also be cause of antibiotic resistance bacteria. It is as serious issue as that. Okay? And ultimately what will happen? When they take these kind of things, okay, which are already having this AMR strain, it will cause ultimately serious disease, sometimes even death. Okay? This is how the antibiotic strains survive, and okay, they can outnumber the normal strains inside the body of any human being. For example, it's a human being or any kind of species, we know what is the normal tendency of any organism? To multiply, to grow, right? So suppose in the system we have a normal bacteria exists in the system of any species. Now what will do, what by its natural tendency, what it will do, it will multiply. That means increase its number. Suppose somewhere it one or two bacteria from that in that population develops resistance. What? So this bacteria is also increasing along with the other bacterial cells, and it is the number of resistant bacteria is ultimately increasing. Okay, जो resistant bacteria है वो उसके numbers बढ़ जाते हैं, and ultimately they outnumber the other beneficial or the normal bacteria in the system of the individual, because they are more powerful. They can wipe out, they can other normal bacteria from the from the system of the species. Likewise, okay, in this way ultimately the AMR strains, the antibiotic resistant strains take center stage, okay, in the living systems of any organism, and causing ultimately some prolonged illness. This is again another problem, which is again a natural property of some kind of bacteria. They can form biofilms. Biofilm means they can, okay, the bacteria can come close and they can form an extracellular layer of certain polysaccharides. Now, because of the layer of the polysaccharides, okay, you cannot treat them or you cannot inhibit or kill them by any kinds of antimicrobial agents, including antibiotics. Nothing will work if the bacteria has developed this kind of biofilm, that is extracellular matrix around itself. Okay, sometimes if it is a normal strain also, none of the antimicrobial agents will work against it. Okay, and this is a natural property again of bacteria. Many places, in the nature, many places, even it can cause these biofilms. Even in our household also, sometimes they can cause this kind of biofilms. So, so we have seen about different processes. Now let us understand how this antimicrobial resistance develops in the bacteria itself, in the system of the bacteria. Okay, so the antimicrobial resistance can be developed in the bacteria by two ways. One is intrinsic. Intrinsic matlab what? It is natural or inherent. By itself the antibiotic and the bacteria develops resistance. Number two is acquired. It acquires the property from outside, from nature, from other bacteria. Okay. So as you can see, it is always intrinsic or natural. It is always, this is a natural phenomenon which is happening, okay, in all kind of bacterial species, or the most, and in this natural antimicrobial resistance, the most common mechanisms are the changes in its cell surface. Okay, we all know that is the LPS, lipopolysaccharide layer in the outer wall of the bacteria, okay, in the membrane. Okay, it can change the lipopolysaccharide, or it can change some of the proteins in its outer membrane, and it can change the permeability of the particular antibiotic. That means antibiotic will not be able to enter the cell because of the changes in the bacterial wall membrane. Okay, and it can also have some efflux pumps. Okay, we have known this. We know about pumps, right? What is the use of the pump generally? To forcefully push anything. There are many pumps existing in a bacterial cell surface, just the tiny organism, okay, to drive out the antibiotics from inside itself. It can forcefully throw out the antibiotics outside from many kind of, like this kind of pumps which are existing in its outer wall membrane. Now, acquired resistance, so we have seen that naturally it can happen. Also, it can acquire this resistance from outside. Okay, there are many ways it can do this, even acquired resistance. For example, it can mutate its DNA, okay, the chromosome. It can acquire some kind of the resistant genes from other bacteria, which is called a horizontal gene transfer. Horizontal transfer means what? Between the same kind of species. If anything, for example, gene is getting transferred, it is called horizontal gene transfer. It can acquire those genes from other bacteria. Also, it can acquire the genes in the form of extrachromosomal DNA that's called a plasmid. There are 3-4 ways it can acquire the gene also from other bacteria. Okay, just think of the different mechanisms that exist in it by which it can develop the resistance. Okay? Now, that's what we are talking about, the origin of resistance. So one, it can develop the resistance naturally, other it can acquire it from the outside of nature. Okay? If we just see it in a little bit more detail, these are the several ways or the pathways by which it can acquire the resistance. Number one, naturally we saw, naturally, it does not alter any target site. Naturally, how does it do? Just now we saw by changes in its cell membrane and by the use of certain kind of pumps which is existing in its surface. Artificially, acquired, how does it acquire from outside, from nature? By both genetic and biochemical methods. Again, in genetic methods, it can do it two ways. It can do by mutation, by changing its genetic component, and also extra chromosomal methods. That means not in its own genes, okay, but a plasmid, that is the extracellular chromosomal DNA from other bacteria, or certain genes itself, okay, from the other bacteria. So it can do in many ways. It can also do it in biochemically. That means by enzymes, by using the enzymes, it can prevent the drug accumulation. It will not let the drug accumulate inside itself. It can modify the target site of the antibiotics or any antimicrobial agents which is being used. It can use different alternative pathways to get rid of the antibiotic. It can quorum sense. Quorum sense means, again, it is a property by which the bacteria, through some chemical signals, it attracts the other bacteria close to it, okay, increases density, forms a biofilm, and inhibit any kind of microbial agents. This shows you of the different mechanisms, both natural, okay, and acquired, through which a simple cell like bacteria can develop resistance and makes the antibiotic absolutely useless. Okay? Now, these are, now going a little bit more detail. So, it is a natural way we have seen that it changes the permeability of the antibiotic. That means it limits the uptake. What else it can do? Modify the drug target. Okay, that means inside the cell, it will modify the target of the antibiotic. Suppose a protein where antibiotic will go and bind. It will target, it will modify it. And it can forcefully drive out the antibiotic from its cell. Okay, this natural drug uptake is a very common phenomenon exhibited by gram-negative bacteria. Okay, so these are certain examples of it. Okay, some gram-negative bacteria like Pseudomonas. Okay, there is a certain difference because of the structure. The gram-positive and gram-negative bacteria can work in a different way. Okay, I'm just just not going into too much detail now. Okay. Because it's a very large topic. If we want to, it will take many actually sessions to completely understand all the different mechanisms. Anyway, this single site slows the different mechanisms by which it can get rid of the antibiotic, the bacterial cell. Okay. For example, it can modify its target inside. It can use the pumps to throw out the antibiotic from its cell. It can, it can modify, that means it can phosphorylate some kind of protein inside it where the antibiotic will be able to go and bind. These are some examples of efflux pumps which exist in the bacteria. All these are examples of pumps or transporter proteins in the bacterial cell membrane which can drive the antibiotic outside. See, just the number of different pumps. Okay. This is a slide, okay, which shows what is the difference between antibiotic and antimicrobial resistance, though being similar. Antibiotic resistance means the bacteria is resistant against the particular antibiotic, the bacteria itself. Whereas antimicrobial resistance means any kind of microorganisms, be it bacteria, fungi, protozoa, virus, it is again developing resistance against the particular medicine or drug which is used to treat it. So, antimicrobial resistance means all kind of organisms which are developing resistance against different kinds of medicines. Okay? This slide shows how it can be spread. As we just saw, there are different ways how this resistance can spread. Not only the drug overuse, from animals, from environment, from livestock, from travel, it can spread. That's why there is an urgent need to treat it in several ways. Okay? You know, this is the integration of different kind of method is called actually antibiotic stewardship. It's a program where different components are being utilized to manage these infections. For example, good healthcare system should be upgraded, okay, and everybody should have access to clean food and water, which is a very important role. And you might all know around SDG 3, good health and well-being for all, okay. Responsible use of antibiotics, possible vaccination against all kinds of bacterial diseases, communication about health issues, making aware, and clean water, clean system. This is an example of antibiotic stewardship program of CDC, okay. So, you know, it talks about, see, at the different levels, the action has to be taken. Okay, this is the different people who are actually involved in this antibiotic stewardship team. This is again an integrated approach for tackling antimicrobial resistance at different levels. Okay. So, you know, very quickly we'll see. Okay, so what are the different mechanisms? First, we have to understand the fight is always on between the antibiotic and the resistant bacteria. It's a constant fight which is going on. Okay, and so the certain new antibiotics, if there are certain alternatives to it, and by good prevention and control measures. These are certain examples of the treatments which are available now. Vaccines, so these all come under immunotherapy against antibiotic resistant infections. Vaccines, okay, bacteriophages means the viruses which actually eat up this kind of bacteria. Okay, antimicrobial peptides, the short peptide or protein fragments which can actually kill again these antibiotic resistant strains. Okay, some natural compounds in the system, in the nature, they are already having this certain kind of, you know, substances which can again inhibit it. Okay, there are many kinds of fruits and vegetables that we take, they have this property. Probiotics like curd and all, why? Because when we take it, it increases the, you know, the good bacteria inside us, the beneficial bacteria inside us, okay, which can again be helpful to get rid of the AMR causing bacteria, okay. And nutraceuticals, ultimately these properties of the good substances of the natural are used up for making some kind of medicines, you know, health additives, etc. Some other things are the antagonistic bacteria. Some bacteria they have found in nature who can inhibit these antibiotic resistant ones. Okay, like, you know, some kind of halophilic bacteria. And bacteriocins, these are again certain kinds of proteins which are effective against similar kind, you know, similar species, and okay, competitive exclusion. Suppose somewhere there is these strains are there, we introduce another species which can okay compete and drive up this AMR strains. There are many challenges though ahead. Many of this therapy we saw now, or possible therapies, they have not been converted into medicines yet. They have not reached the pharmacy yet. There is a lot of research still needed to be done. And similarly, we have a lot of scope is also there. Okay, so it's a continuing field of research. And so road ahead is challenging. We are slowly moving to a pre-antibiotic era. Okay, where meaning the stage where there was no antibiotics, because now all the antibiotics are ineffective slowly. Okay, so we have to all the important health regulatory agencies of the world like WHO, CDC, even ICMR, they have realized its importance and they have come up with many kind of strategies, policies like okay the AMR antimicrobial resistant research and surveillance network of ICMR, our own body in India. Okay, Indian Council of Medical Research. Okay, but we should also take up certain steps like good hygiene and healthcare, which can inhibit these kind of infections along. Okay, so okay, one of the last slide. Okay, the last slide actually. This tells what as individual we can do. हम लोग सब individually कर सकते हैं to lessen the burden of this antimicrobial resistance and the resultant mortality worldwide. Yeah? We should use antibiotics only when prescribed by a health professional like doctor. Never use it alone. Never ask antibiotic if it is not prescribed. We should always complete the course as prescribed by the doctor. Okay? Jitna din lena hai, okay, in the required concentration we must complete it. And follow the doctor's advice. Prevent, we should always maintain good health, hygiene and sanitation so that these can be avoided, this kind of infections. And choose foods that have not been produced by these kind of, these don't have, in any way this antibiotic resistant bacteria, okay, or any kind of, use of antibiotics. And prepare food hygienically. Always in our domestic setup also, we should always clean everything properly before being used. Okay? Anyway, in our Indian system, cooking food at high temperature itself is a antidote, because most of the bacteria or the organism get killed. Still, we should do it very, very hygienically, wash everything very properly, then only cook it or use it. And spread the word, okay? As much as possible. That means make each and every person aware the what are the danger, how it can spread, and how we can prevent it. So ultimately, the situation is very grim. All the bacteria are after the antibiotics. That trying to get resistance against it. But okay, it is not the end of the road. If we do it in an integrated way and all together, we can still stop this antibiotic resistant infections, okay, or the AMR. And thank you so much for all of you for your patient hearing.
I think that was a real marathon, right? You are going to go for a marathon in the evening, I know. But I think he really, to make you all aware about AMR, and with the time that we have given him, he has tried to do the best justice he could. But I think this is a topic for research for y'all also, to see what y'all can do, because this is the thing that has started already. I think everyday newspapers, we are having one or the other news talking about this. I think couple of days before, the doctors have been instructed not to give antibiotics during the cold and this. So that has also come into the newspapers. So it is a serious issue. And I think who better than the pharmacist should know about it. So I thank Debashish sir. It is his area of research, so you can see the kind of data he might be coming across every day, and through the kind of research he has been doing. So that's the concern that you could see into his voice.
I just wanted to add one thing in relation to now in my group. Actually, I'm working with the therapeutics for this AMR antimicrobial resistance now in 3 different ways we just saw. One is the antimicrobial peptides, which is being done by one master student. Recently we have submitted a DVD grant for that. We are also actually working on bacteriophages and the antagonistic bacteria. These 2 of my PhD students are actually doing it. So one, so the antagonistic bacteria are actually the halophiles which he is using, which has been isolated from marine coast, okay, around in the Saurashtra region. Okay, so these are 3 different therapeutic lines which my group is working, and we are seeing how it can progress. But my next interest is to also look for the diagnostic part, how we can identify these kind of antibiotic strains in different clinical samples.
So, for those of you who are interested in research related to this, I think sir would also be happy to help you out with the data. And I think this is what Atma University is doing. I just wanted you all to know what even the biotech department is doing in this concern. Thank you, the faculties, for bringing the students. I request Acharya sir to please give a small token of appreciation to Debashish.